time for another driftphysics.com video presentation. So in my subscription box, a Dr. Lincoln Fermilab video on what is energy. So yes, let's go watch that together. So yes, I should maybe play the video first, blah 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 blah. No, I don't really need to. Really don't. So this ought to be funny. Everything happens for a reason, and that's the reason it usually, and that reason is usually physics. So they don't really have reasons for anything. They still don't have any explanation at all for magnetism or for gravity. They draw their little atom, and they have no explanation for how the electron is doing all this moving around. Or they don't even have really a real force holding it together. Frankly, because charge wouldn't be good enough. But anyway, I mean, as a gravitational model, it wouldn't work.
Energy is one of the more fundamental concepts of both classical and modern physics.
Okay, so it's not just a concept, it's a thing. It's a dynamic that makes the universe possible, right? I mean, there's nothing could happen if something wasn't happening. So it's the part that makes everything happen you can put in the category of energy. So I'll just do a quick... So defining it, and saying energy is... Alright, a word definition would be something like, well, there's little bits in the universe, okay? We'll call them force bits, and they move the speed of light. And when they interact with matter, the matter acquires the essence of the little bit. And then the little bit can interact in such a way where it gets hit by another little bit, and both forces are released as free energy again. So inner force can be trapped and stored, like between two ping pong paddles. So there can be force just flying through space, a little bit, a quanta of force, okay, and it's all flying through space. Your cell phone call is made out of these little bits flying, and they're actually flying with a little bit of a pattern, and the pattern is where the information is. And that's also for gravity and magnetism and all. It's all made of just this little stuff. And the trick is that it flies free from here to there. So like when you see a photon of light coming from some far away distant object, the photon probably could have, well anyway, doesn't really matter. It got stored inside of a little sun. It's now leaving the sun. It had a history before the day it got stored in the sun. But anyway, it leaves and then it travels billions of light years and hits you in the eye. Little bits with a pattern. Bits, 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 then no bits, then bits, 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 and then no bits, and bits, 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 and this is just the Morse code, essentially, of the photon. This would be a photon that hits you, made up of these little bits. Anyway, moving the speed of light. So you're just getting bombarded by little tiny asteroids, and that's energy. And the energy never stops, so it hits an electron, and it sticks to it. And it waits for some day when another bit hits. It won't be a very long day. It'll be, a trillionth of a second for another bit to hit from the opposite direction, and then both little bits will leave and go back to being free in the universe, and the matter will stop moving, the electron. But if more bits hit the electron from this side over a period of time than hit from this side, then the electron will collect those and move in that direction. And not until it encounters more force from this side hitting it will stop, and then have to start again. So it starts, every piece of electron matter goes from stopped to moving, and then has to stop and then move in some other direction, okay? But it always has to go through the stop phase. But anyway, but that's all that the universe is. It's just made out of this little stuff, then electrons and protons that aren't doing anything at all. The energy is this little bits, these little asteroids hitting all the bigger pieces of matter and basically sticking to them and then unsticking. But you can trap, so you have free energy that's flying through the empty space, and then you have energy that gets trapped between two electrons, for example, and it just bounces back and forth, and it can do that for 1 trillion years. And then one day this electron goes down and this electron goes up, and then the little bits are free not to hit anything again. and they're back into the field energy. But that would be, very hard to just write a definition of energy. It's force, okay, moving the speed of light, made of quanta of energy. Something like that. Quantum bits. So, back to the video and such. Might not need this for a while. Anyway.
But just what is?
Let's make sure the volume is right. I probably could turn this down. So there's not too much echo.
Energy. That's an excellent question with a lot more to it than you'd think. Every time you look at it, you learn something new. Let's see if I can surprise you.
No. You'll just try to confuse, and then their whole explanation is dependent on them not understanding that gravity is just part of the same system as all other systems, and it's just taking some of the energy out of the field, and essentially making it move matter. And when the energy has to move matter, matter moves slower than the speed of light. Therefore, the energy is in a way diminished a little bit. And that little bit of diminishment in the potency of the energy, because it's pushing the heavier matter, is what's causing the force deficit called gravity. It's a little bit pathetic that the world needs this, and that science people even need this kind of crapola. Yes, waste a few seconds of my life.
Energy is easier to recognize than define.
Whatever. Recognize? No, most of it we don't recognize. Most of it we can't see. It's little tiny stuff. Most of it's trapped inside of atoms. Well, I can't say most of it. That would be wrong. A lot of it is trapped inside of atoms for us anyway. We live in a world full of atoms. Because we can't live in empty space.
You know it when you see it, like a speeding race car, a taut bow, and this may be the most energetic thing known to man, a group of 4-year-olds who've been fed espresso.
Oh, whatever. I mean, that's just too... Yuck. The gratuitous family fun moment.
On a bag of gummy bears. Scientists try to make the definition a bit more precise and say that energy is the capacity for doing work.
All right, which doesn't mean anything. That's saying absolutely nothing, because the only thing we call work is the stuff we consider work. So they don't call it work. Right? I take this battery, I put it in my hand. It's not moving. No, it's not work. Actually it is work. I'm constantly pushing the battery up against the force of gravity. The force of gravity makes the battery have weight, pressure on my hand. My hand has to push against it. It's constantly work. They don't think so. Most of the work in the universe they don't consider work, because it doesn't involve something actually that we can physically see the change, even though the changes were happening. The whole time I was holding the battery, I was actually pushing it up, and it was pushing down. I was pushing up. Atoms were actually electrons and protons were actually moving on the surfaces of my hand and the battery. There was a pressure differential between the two, constantly stuff going on. Lots of work being done. And this is Fermilab. They're supposed to know about the little tiny stuff in the universe, and they don't get it.
That doesn't help most people, as physicists use the word.
Yes, because it's circular. It's just replacing one word that you didn't define with another word that doesn't have any good definition. So yes, that's like saying it's like googie, and it's just like pookie pookie.
Work in a technical way. Colloquially, I think that you might call energy a property of things in motion.
Okay, so yes, things in motion. That's all you need to hear. Energy is things in motion, and you can go all the way back to the elemental things in motion, or you can understand that a thing that's moving has a differential of elemental things that are moving, and the differential in elemental things that moving means it's going to move in some kind of direction because it's been exposed to a differential. More stuff from one side has hit it than stuff from the other side. That's why it's moving, and that's the only reason why it's moving. Can't move any other way. than to get hit by more stuff on one side than the other side.
Or something that could, in principle, cause something to move. There are many different kinds of energy. For example,
So now there's only one kind of energy, and it's just movement. You can move electrons, you can move protons, you can move atoms, you can move compounds, you can move bricks, you can move buildings, you can move earths, you can move galaxies, you can move all kinds of different size things. And that's all these different names are for. Okay, now there's no such thing as potential energy. So the difference between potential and kinetic just means potential and active. So let's get rid of kinetic because that's uglified by the silly mv squared nonsense. So there's active energy and kinetic energy. So that would be different. The difference between the energy that we receive as photons, that are the active elemental bit traveling through empty space, and then the potential energy would be energy that is trapped inside of an atom, or the energy that the atom has because it got hit by more energy from one side than the other. It collected it. Collected energy. So thermal energy is just atoms, okay, that have been hit by more energy from one side than another. Okay, electrical is electrons, obviously going through a conductor, so exchanging between atoms. So they're not free. They have to be connected by atoms. You have to have a connection of atoms to have electrical. All right, chemical, and now we're back to another form of electrical, in the sense you're doing transfers between atoms. And then nuclear would be the fact that the atom itself has a bunch of little bits inside of it between electrons and protons that are holding it together. The electrons are repelling each other actively, the protons are repelling each other actively, and the inverse is happening in terms of the attraction between electrons and protons, and that balance between those two is being created with a lot of energy. And etc. is just plain bullshit. There's no etc. energy.
potential, kinetic, thermal, electrical, chemical, and nuclear, to name a few. The big categories are kinetic and potential.
Okay, so that's not it. They have nothing to do with categories of energy. They're just states that energy can be in. So they really don't have anything to do with getting to what energy is. Okay, the difference between the ping pong ball trapped between two electrons and a ping pong ball flying through space, that difference has nothing to do with the ping pong ball at all, understanding the ping pong ball. So that dynamic isn't really energy.
Kinetic energy is the energy of motion, be it translational, which is a fancy word for, moving, or things like vibration or rotation.
So exactly the same thing, which is moving. Vibrations are moving, okay? Rotation is clearly moving. So, linear motion versus circular motion, again, just all motion, doesn't really matter. It's just about masses being moved by something. And something that's moving them is force. And the forces all travel at the speed of light. There's no difference between the force bits that make up photons or gravity or magnetism. All the stuff moving the speed of light is the same stuff. All right, it's just in a different configuration. It's a parade where people are lined up a little different. That's it. Same people. They're just wearing duck suits in one parade and tomato suits in another.
The first kind of kinetic energy you learn about is translational energy. If you have
You just said that. So this is hardly the first energy you learn about, is this stupid kinetic energy 1/2 mv squared nonsense. So we know he's not going to talk about Leibniz, and we know he's not going to talk about the failed experiments, and we know he's not going to talk about the fact that they didn't put the half there until the 1840s, and they still thought they proved mv squared. None of the history will be part of this story of energy.
have an object of mass m with a velocity v, then the translational kinetic energy is 1/2 mv squared.
Says them with no evidence, no physical experiments. That theory can't pass a lever test. A lever proves it doesn't happen. They've just been spouting this nonsense for, like, in the first form it was mv squared. So just understand, for the first 200 years it was just mv squared. And then 1840 they shoved a half in there. It was wrong before, and that was, so they made it half as wrong. So it's still very wrong.
By the way, a future video will explore that equation.
Oh, please, yes, please do that. Yes, explore it with your, and just lie through the whole video. Yes, please. So again, just validate my previous criticisms of the shoddy crap science you do in your videos, Dr. Lincoln.
Much more detail. Potential energy is stored energy.
There you go. That's all it is. So why you keep calling it something else? It's just stored energy. So why are we calling it something else? It's not energy like stored in any kind of, and the way the storage is, like gravity, it's not really storage. Waterfalls are not storage. Okay, it's active kinetic energy, right? The kinetic energy of the water is what you're collecting. If you have a windmill, it's not potential energy, it's kinetic energy. The wind is kinetic. You're collecting kinetic energy. So this whole idea that it has something to do with a potential. No, it just has to do with systems store energy. And that's a fact in circular ways, in ways that, like traps, like going back and forth. Like a dead end or a cul-de-sac, and you just go spinning round and round and round and round, and at any moment somebody can let you loose, and now you're free again. You can do work in the universe, but you're no longer trapped.
It's usually created when an object is moved against a force, like...
So there's no moving against a force, so there's no countering force. It's just that you have to give somebody $5 for them to have $5. Okay, there's no other way to do it. They can't have $5 unless they get it from something. All right, so there's no force you're acting against. You're not fighting something's willingness to move. You just have to give it the move. You have to put gas. If it's a car, you have to put gasoline in to make the car go. It's just a fact. The car isn't resisting. The car says, "I'm not going anywhere." No, it's saying, just put the gas in, I'll go.
Stretching a spring or lifting an object against gravity. It's called potential energy because while the object isn't moving, it will if you let it go.
Right, but it's just not accurate to say that the energy is in the form of potential, because it's not in the form of potential. These are active streams we stick our propeller into, our water wheel. You don't call the stream, again, potential energy. It's kinetic energy. And gravity is just another stream that you can stick a wheel into. Everything is just a stream. Stick the wheel into it. See if you can get something to happen. The problem with gravity is we can't fix ourselves to any object to be able to collect the gravity, to collect the stream. We end up moving with the stream.
Potential energy generally depends on the strength of the force and how far you move an object in the force field. The most familiar form of potential energy is gravitational. If you lift an object and drop it, it moves downward.
That's not much of a use of a microphone. It's kind of a funny, of all the things they could have chosen to drop. Yes, and it drops forward. Just understand. First, you were holding it against gravity. It wasn't just in some place staying there. It was an active stream. You're holding it in the active stream, and you have to do work to keep it in the stream. And then you let it go. Well, you could also just let your arm go, and your arm's going to fall because of the gravity. So you had to do work to be in that potential circumstance.
Lift it higher, which means move it longer distances against the force, it gets more.
So it doesn't get any more potential. You just go into you stay in the stream longer. So you go further upstream and put your object in. You go further up and allow it to gain more velocity.
Potential energy. And of course, that means when it hits the floor, it's moving faster than if you only lifted it a little bit. We think of energy.
So that's not a very technically accurate way to describe it either. The longer, it's all about how long you're in the stream. So he's not even going to describe gravity for what it is. Okay, a stream of energy. And you're getting bombarded, just like rain. And how long you're in the rain will decide how wet you're in. Okay, you can't change how wet you're going to get any other way than changing how long you're in it. That's how you get wet. And obviously, if you hold something in the gravity or stop it from moving and gaining velocity, yes, you can stop it from getting wet.
Energy as being a concept that originated with Newton, but it didn't start with him.
So yes, so it's no point in mentioning these people because you just slander them with this horrible physics. So he said these are the concepts: potential energy and kinetic energy, and then he showed you the 1/2 mv squared formula. Has nothing to do with Newton, Descartes, or Galileo. All those people are innocent of believing in this nonsense, this fairy tale, this absolute bullshit. Newton opposed it overtly as bad physics. So again, they're trying to put this bad physics and put Newton's face on it, okay, as if this is Newton's physics. It's not Newton's physics. It's against Newton's physics. It's opposing Newton's physics. It's changing Newton's physics. It was invented by a person who didn't like Newton's physics. That's the true story. A guy who, right, as Newton was showing the world, he could accurately predict using momentum. He accurately predicted all kinds of celestial events, proved to the world he had the right physics. At that very instant, this other guy was saying Newton's wrong and you shouldn't believe him, even though Newton was getting explicitly right and correct answers.
He thought the important thing to describe motion was what we now call momentum, which is just equal to mass times velocity.
There you go. So I don't know how's he going to get out of this. Now he's brought up this other competing theory, and he's going to somehow say these two competing theories can sit there and just, wallow in the same reality pool. They cannot. They're dramatically opposite ideas. MV, okay, saying a $10 bill is worth $10. Okay, I mean, we have to do something where you can change the length and the height or something. But I mean, the very idea, okay, just the dramatically different notions of what makes something have energy between understanding it's just how much mass moving how fast. And to sit there and say that this other formula that says square the velocity and then do that, somehow have compatible answers. They're completely incompatible.
On the other hand, a contemporary and rival by the name of Gottfried Wilhelm Leibniz championed something closer to what we now know as energy.
So that's hilarious, right? So he championed, and let's understand, he died a nobody, okay, completely rejected as having any scientific integrity and all that kind of stuff. Nobody liked him. Nobody went to the funeral. And Newton was buried as a god. All right, so for 20 years they lived through this disagreement, and Newton was such a resounding winner in the argument because there actually was no argument for this, what he championed. He championed it without having a single piece of physical evidence to support the notion. So he championed an idea in science without any evidence supporting it. He lost the fight, and then somebody resurrected it and won the fight, which is hilarious. In terms of, they didn't have an argument either. But they did contrive some little experiments, little ferrocell magic experiments.
He thought the quantity that mattered was mass times velocity squared. The reasons for the two positions were largely philosophical.
It's not really true. The reasons Newton believed in momentum is because it got right answers. It had nothing to do with philosophy. It explicitly diagrammed what happened. He could diagram anything in the universe knowing its mass and its velocity. He could diagram what was going to happen. He could predict its motion. That's why he believed in it, is because it got right answers. It was Leibniz who didn't like physics being too simple. I mean, in a sense, he argued for the fact that there's a physical universe and it doesn't, it's running, which is the irony. But clearly, there was something about Descartes he didn't like, and so he challenged a foundational idea of Descartes, which is the energy in the universe is the only energy there is, and it can't be manifested in any other way. Okay, there's no souls being created. So you can only make a new soul, so to speak, out of a dead soul. So maybe that's what Leibniz didn't like, is that for him to turn energy into something spiritual would require souls to be made out of dead souls. because Descartes was basically saying all the energy in the universe is made out of biodegradable, reusable resource. That the heat you create with the floor and other things does cause the lava eventually, and it does, it's all related. The same, there's all a certain amount of energy in the universe, and that's all there is, and we're just following it.
And it took a French intellectual by the name of Émile.
So again, this French intellectual, no, an elitist, okay, who got good tutors, and one of her tutors was a Leibnizian, okay, an overt Leibnizian was one of her tutors. So this wasn't something like she originally, with her intellectual prowess, discovered the brilliance of Leibniz. No, she was basically brainwashed into it.
Du Châtelet to sort it all out.
She didn't sort anything out. She did these silly little experiments, dropping crap into clay, a biased substance, a substance that doesn't treat slow things the same as it treats fast things, and sand experiments that any physicist should be able to understand that it's not about how many pieces of sand you shoot how far. It's about how many total pieces of matter you move. And if you measure the energy between two things based on how much sand they move, okay, then MV works every single time. And MV squared is not the right answer. Fast, light things don't have more energy than big, slow things. That's the real truth. That's what all the real physical evidence demonstrates. And these little show experiments shouldn't have fooled scientists.
Dropping steel balls into a bed of soft clay,
Well, they were lead, but whatever.
Found that the depth.
She didn't find it. See, again, this is such a lie right there. She didn't invent these experiments. This was Goddefield, or whatever his name was, some, I think, Danish guy or German, who did the experiments. And she just found them interesting because they agreed with Leibniz's theory. So again, these were just people trying to contrive evidence to support this MV squared notion. So they made experiments where they could force those results. And not enough people cared to poke at those experiments to see, well, gee, is clay really a good way to measure how much energy something has? Or does clay heat up when you shoot a fast thing through it, and does it yield more the warmer it gets? So the warmer I make the clay, the faster an object goes through it.
That the balls penetrated depended on the height from which she dropped them and the square of the velocity at which they hit the ground.
So, and again, not duplicated experiments, okay? So these aren't experiments where you have somebody who redid them and made them come out all this way. And certainly you could make them come out any way you want by just changing the temperature of the clay. So again, terrible, terrible experimental evidence, just garbage. And a lever, by the way, okay, just diagram a lever. A lever proves what she says can't be right. What she defended can't be right. Just a fact. And according to Voltaire's testimony, she wasn't too impressed with Leibnizian theory by the time she died. So, but who knows?
She also proposed the idea that energy was conserved and worked out the formula for gravitational potential.
So this is more absolute nonsense. Conservation of energy was an overt statement by Descartes. His whole philosophy was based on this idea that the only energy in the universe was the energy God threw into it in the beginning, and that's all there is. And it's just being recycled. It's just moving through the system. So conservation of energy, it was a Newtonian idea, it was a Galilean idea, it was a Descartesian idea. They all had that idea. So again, just more propaganda. I mean, that's just a lie to say she worked out any conservation theory. She didn't have any conservation theory that put anything new on the table at all.
Energy. Some have considered her work as the time where the importance of energy began to be appreciated and formalized.
It's when everything went off the tracks. Now the train has hit a bump, it flew off the tracks, and now is there any hope that a good thinking, intellectual, smart people will say, hey, wait a minute, we don't have any evidence. Hey, wait a minute, we don't have any good theory. Hey, wait a minute, we can't even survive a lever test. Hey, wait a minute, none of this makes any goddamn sense. It all sounds kind of silly. The smaller and smaller, she even argued the point, you know, that a grain of sand could blow up the universe that you have this preposterous increase in the amount of energy things have. I mean, she even made that as in one of her arguments. She even exposes that truth, and she had some catch to get out of it, but there was just a catch.
No one individual can be credited with developing the idea of energy in all its forms.
So that doesn't even make any sense. I mean, these are obviously concepts and ideas that were asserted and formalized by individual people who, did that. They're all part of the process. You wouldn't believe this crap if it wasn't for her being rich and capable of publishing this nonsense and, frankly, fooling everybody. It wouldn't be a fact. Okay, without her, this idiotic notion would have never occurred to anybody. And you would be perfectly satisfied with momentum. And you'd have completely different nuclear physics because you wouldn't be able to give tiny little particles infinite amounts of energy. You wouldn't have made dark matter. You probably wouldn't have made dark energy for sure.
It took decades to work it all out.
Okay, so to work out all what? It's not that complicated. MV versus MV squared. So he says it took decades for them to figure out, well, you know what? MV squared gives answers that are outright silly. The grain of sand blowing up the universe. So let's put a 1/2 in front of it. Oh, that'll save us. Now we didn't blow up the whole universe with a grain of sand because now it's half as much energy. So that's a lot of energy we took out of everything. It's still way off. Okay, you still have an imaginary notion of energy that's way the hell off.
And included input from famous physics names like Carnot, Joule, Bernoulli, Boltzmann.
Right. Some of these people believe, some of these people did not. So some of them are just getting thrown into the mix, because that's the mix. But what Joule did was basically create experiments where, frankly, you could demonstrate that this energy doesn't exist because, energy is the work it can do. And heat is part of the work it's doing. If something's making heat, it's using up fuel to make the heat. These are all kind of facts. Yes, so Maxwell was a wavist and etherist. Yes, some of these people were biased.
Then Maxwell and many others. In the modern world, we can think of kinetic energy as things that move, like translate.
So he's out of the history. So he just ignored the place where they put the 1/2 in front of the MV squared. So all through that time, all the way up through Maxwell, the theory was MV squared with no half in front of it. So it was getting completely insane answers. And so he didn't even point out that after all those people was until you threw that 1/2 in front of it.
Rotate and vibrate, and potential energy being when an object is moved against a force. That force arises from some sort of field interacting with some kind of charge.
Okay, so says you. So obviously it doesn't have to be a charge in the case of, directly charged. The charge is equal in the concept of gravity, so the charges doesn't really matter. But it really does matter that there's, you're pushing either protons or electrons. What you push them with does subtly matter, but the fact is it doesn't matter that it's still just mass and velocity. So it doesn't matter that the proton is a charge and the electron is a charge explicitly, but clearly it does if you want to be technically correct. So in some respects, charge is the function of transferring the force from being free to move in the universe into something material significant in the sense that it has to move electrons and protons. So what the little bits always hit are electrons and protons. They don't hit anything else. They just hit electrons and protons. So they can move electrons and protons. Obviously, you hit electrons and protons, you can move the atom that is made out of the electrons and protons. So if you hit the electrons and protons enough, then the whole atom's going to move. And then you're off to the material moving races, so to speak.
Examples include an electric field and charge, or gravity and mass. In cases like those, if you're
So it's just another gravity example. So why didn't you just reuse his microphone one? Blah, blah, blah. Just hilarious. I'm sorry. It's such a simplification just to show gravity and not explain. There's no arrows here. There's nothing explaining what the hell this is. I let go of this physical piece of matter changed its bond, its tension with this one. And now this one, because it's not connected with an arm, okay, to a body that's grounded to the ground, okay, that's pushing force into the ground, this one's falling because it doesn't have any way to know that it's connected to the ground. It's not connected to the ground, so it can't, stop moving. There's no counter force, so to speak.
These objects, they will begin to move, and this will transform that potential energy into kinetic energy.
So again, it's not anything called potential energy. You're just dropping something. You're letting something go in a stream, and the stream is taking it.
Now, just why energy is such a big deal was originally pretty mysterious.
Okay, so look, there's no universe, there's nothing, there's no talking, there's no anything without energy. So why would, of course energy is a big deal. Energy is the entire function of the universe. The universe, again, we have no intelligence, we have no function, we have no anything. There's nothing happening in the universe if it wasn't for energy. Energy is the whole dynamic that makes the whole thing dynamic. There's no dynamic without it. There's no anything. I don't, so of course it's the subject. It is the most important subject there could possibly be, because it's why everything that happens. It's cause and effect. There's no effects. There's no difference in the universe if there's no energy to cause the differences. You can't, every event is dependent on the energy causing the event.
And it only became clear when German mathematician Emmy Noether realized...
So this is another little special niche piece of cruddy little physics they throw in here, and this doesn't have anything to do with anything, frankly. This is just so abstract and unrelated to anything that could matter.
Something enormously profound about the universe. She realized that conservation laws were a consequence of symmetries in the laws of nature.
So again, just silly. It has nothing to do with anything. The symmetries are obviously a consequence of conservation. Conservation is the symmetry. Conservation is the obligation to, obviously, if there's more stuff hitting me on one side than hitting me on the other side, I have to go this way. Things moving from high pressure to low pressure. That's already the symmetry. That's already telling you that it's, that there's a, obviously there's a symmetry in the sense that you understand that, yes, it has to be equal pressure on both sides for the thing to stay where it is. So, I mean, it's so circular. And to say this was some sort of new finding that matters, it's just overhype.
If the laws of nature were unchanging over time, and I mean the deeply fundamental laws of nature, then energy would be conserved.
And it is. Duh. So, I mean, it's just, and that is to say unchanging. Conserved. The same amount of energy is always in the universe. The same amount of little force bits. And the force bits are either, you can be a force bit. You're either free, you're moving through empty space, waiting to hit a helium atom or something. I don't know what your next little story is going to be. But right now, there's little bits of force flying through the universe, and they're free until they encounter an atom or something, and then they'll be, the atoms will do something, and they'll be stuck on an electron, and they might be stuck for 1,000 years or 10,000 years, who knows. Anyway, but that's only two states you can be in. You can be a free piece of little force flying through the universe, or you can be stuck to an electron and proton pushing it. So you're either Sisyphus, pushing your boulder, or you're free and you're flying like a bird or something. That's it. That's only two states the energy can be in.
That is to say, unchanging. She also showed that if the laws didn't change with location, then momentum would be conserved. But
yeah, we already know momentum is conserved. There's absolutely zero evidence you ever destroy energy or create energy. So again, it's just not even a subject. It doesn't even make sense that they needed a mathematical proof. You don't need a mathematical proof. It's in every fact that we know about the universe. The fact that there is no free energy machine proves the fact. You have to steal the energy from some other source, some place that already has it. You can't make it. Oh. Anybody says, but that's a topic for another time. So he said absolutely nothing. He just wanted to throw her name in. I don't know why they all want to do that. I guess because Nutter is kind of a nutty name. I don't know. Maybe that's why they want to throw it in. She's a woman. I don't know.
That's a topic for another time. And I made an entire video about Emmy Noether, which you can watch if you're interested.
And garbage. But anyway, let's continue.
I put a link to it in the description below.
Exciting.
So I've told you the...
So again, this is all dependent on, you know, they're glued to mv squared because mv squared created all this super energy in subatomic particles, and the standard model is all based on just measuring the energy of a particle, but they're not really measuring the energy of single particles. They're measuring the energy of a collection of particles, and they're calling that a new particle, like a quark or a positron or some other stupid nuon, gluon, puons, all of that nonsense. It's all just saying there's a collection of energy of a certain amount, and that amount they're calling a name.
Physicist's definition of energy, and I gave you a rough definition of what kinetic and potential energy are.
So he didn't give us any definitions, right, that really made any sense. There's no such thing as a potential energy. There can only be a potential location. You can be in a location where there's a great deal of risk that you're going to get moved. Like you can be thrown into a stream of water. There's a great risk that you're going to move.
And I ended up telling you why energy is conserved.
Okay, so that's another silly point where somehow Nutter proved that energy is conserved when we already knew it was conserved. And it certainly wasn't conserved because of some symmetry. It's conserved because there's only so much energy in the universe. And so, yes, if I throw something in the universe that way, it means there's more pressure on this side of the universe now than this side. That's just a fact. Okay, so if I pulled one piece of energy out of the universe, I'm going to change the differential between the two sides because it's either going this way or it's going that way, so to speak. So whatever moment I decide to pull it out is the moment I've changed the universe and made one side of the universe imbalanced.
Is that it? Are we done? Well, not yet. For one thing, so far what I've talked about are objects with mass. It's not only massive objects that can have energy. Massless photons...
Okay, so we know there's the whole concept just made up again. They have no proof that there's anything called a massless photon. It's just, again, this is just made up crap. I can't even blame it on somebody because nobody made up, no individual made up well, let's just make photons massless. So they have momentum, but they don't have any mass. And somehow that makes sense, even though it's mv. Obviously, if this m is 0, the v doesn't matter. You can't have any energy. You can't have momentum. It doesn't make any sense. So there's no reason to think a photon is made out of massless particles. That a photon is a massless particle, or that the photon, the bits that make up the photon, are massless. There's no reason to believe that, because they clearly have momentum. Alright, well, I'll pause there, and I have to do some chores, and I'll be back at some point in the future, after some energy has moved to different locations, and the universe has changed. Alright, should be back. Things should be normal.
Also carry energy. Photons are moving ripples in electromagnetic fields.
So moving ripples in electromagnetic fields is saying absolutely nothing. It's not a physical diagram, not a physical explanation. It's not really physics. It's just wooey, mushy, la la la. Angels push the devil's minions into the pit of Beagle Boggle Boogle. It's just, yeah. It's just fables.
So moving fields have to be added to the list of objects with energy.
Okay, the moving fields, objects with energy. So the fields are made out of rays of force. Okay, that's what Maxwell's diagrams clearly show. Charge is rays of force emanating. And yes, the further away you are, the less rays that'll hit you. And the closer you are, the more rays that'll hit you. Blah, 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 blah.
And of course, Einstein showed that mass...
So he didn't show anything again. He didn't like open a magic pop-up book that had physical crap in it. He said something bent space. He did cheap metaphors of bent fabric. Doesn't really work. You need gravity to push things into the gravity well. I mean, it's circular. It's not an explanation. If he has to really say what it is, then it's like a vacuum cleaner inside of every material object that's sucking space. I mean, the whole thing doesn't make any sense, and there's no outlet to the vacuum cleaner. I mean, it's just, frankly, garbage. As is this picture, you know.
Energy were equivalent and mutable.
Okay, so energy and matter aren't equivalent, but matter does take up space. And when matter displaces energy, that is, when you put matter in a field of energy, a bunch of little BBs flying around, and you put a big blob of matter in, you confine the space the BBs had to move in, therefore increasing their likelihood to hit a surface, doubling it, in fact. And by creating more impacts, you create what looks like more energy. You, in fact, didn't make more energy, but you might as well have, because in a sense you doubled the speed of every particle because you gave it less space to move in, less space to traverse before it hits a surface. And that's energy. Same one ping pong ball bouncing between two paddles. If I move the paddles closer together, the ball bounces twice as fast, right? If it's twice as close. Twice as many impacts. Impacts are where energy is transferred. And impacts are the only way energy can be known to exist. Energy can't do anything because it can't interact with energy. Energy can only interact with matter. So the forces can only interact with matter. The bits that we call force only interact with matter.
Can change one into the other and back again. That doesn't make...
So it's really just saying again that the matter displaces the same space, okay, an amount of space which is equal to an amount of energy that would be in that space if the matter wasn't occupying the space. So in that sense, they're convertible.
Much sense from a classical point of view. After all, a stationary and mass...
So if, their view of classical is to put the blinders on and a telescope and a microscope and a distortoscope and a kaleidoscope and make a mess out of it. Obviously a classic theory can make sense of the universe because you don't just draw a circle and say mass. Okay, you're more specific in what you're arguing.
...of object in outer space, far from all gravitational fields, has mass, but it isn't moving. So in my example, it has neither kinetic nor potential energy, but it does have mass.
Right, and mass is made out of the electrons and the protons, and we know that they're always going to be energetic in their interaction with each other because they attract and repel. So that's the catch. But that's the only catch. There's no other catch. The matter contains energy because you're combining a bunch of particles that are mixing their tension with each other. It's a very tense, stable relationship that's created. And that's why there's only 100 different configurations of electrons and protons that are stable. Is because it's not easy to find the geometry between all that different tension.
If mass is energy, then something isn't making sense, since energy is present without...
So mass obviously isn't energy, but mass is what gives energy meaning. There's no meaning to the force unless there's matter for it to push. And when it pushes the matter, then it changes what the force is going to do. So if I move my hand forward, right, it's a piece of matter, it's reflecting force, energy, light. And it reflects more when I move it away towards you and less when I move it away. And so I change the universe by changing the position of the matter. And I change the position of the matter by applying a force differentially to push it one way or the other. I apply pressure. My arm actually applies pressure to my hand and pushes it. Okay, that's what happens.
Kinetic or potential energy being present. The situation is resolved when you look deeply into the fundamental...
So, blah, blah, blah. They think they have a deep understanding. It's wrong. Okay, it's a crooked, convoluted, contrived, full of facades, full of fake buildings with just the word store on them, but there's no store. You can't go in there. There's no real physics, no real science. Okay, bent space, fields. These are just words, and they don't have anything really mechanical to replace the words.
Nature of mass. When you do that, you find that ordinary mass is located in the mass of protons and neutrons. And
okay, so again, protons and neutrons is another story in a sense, that the neutron is just an electron and a proton. The neutron is already a composite object, so yes, but it's just electrons and protons. Everything's just made out of electrons and protons. There is no other ton. That's it. That's all there are. Electron, proton, that's it for matter. Matter's done. And all the other crap is just a combination of electron and proton and movement. That's all there really is. There's no room for anything else. There's no function for a neutral particle. A neutral particle couldn't play a role if you really think about it. So neutral means dipole. Electron at one end, proton at the other end. That's what a neutron is. It's a dipole. It has as much of one as it has of the other, which means it's neutral in total from a distance. But up close, a neutron has a red face and a blue face. I mean, this drawing isn't that far off, in the sense that the neutron has the electron tied to it. And if they really did this correctly, then they'd figure out, well, if this electron that's on this neutron came in contact with a proton, then it would stick also. Yeah, there you go. Atom. That's your hydrogen.
you look into where their mass comes from, it comes from the motion and forces governing nearly massless objects inside protons and neutrons. Indeed, the nuclei that make up each and every one of us are tiny vortices.
So he says vortices. They have no evidence of any vortices, so this is all just talk. All this energy in terms of motion. It's not motion spinning, it's not motion doing all those kind of things, it's motion just doing this. The universe is constantly jiggling everything because the universe is hitting you with a billion things from one side and a billion things from another side. And at any one moment, you can have 1,000,000,001 over here and 1,000,000,002 over there. Any one moment, you're a little like flipping heads and tails. You know, you're a head, you got more heads than tails, and then you can have more tails than heads, and it just keeps switching back and forth, and you get just stuck in this this imbalance. There's never a perfect balance for an electron. It's always being jiggled somewhere by the universe.
Subatomic tempests of moving and nearly massless particles held under strong force.
Now we have nearly massless particles. What's a nearly massless particle? Electron and protons are not nearly massless. They're serious momentum. You start moving atoms around, you're talking serious momentum. So again, this isn't about anything nearly massless or anything massless. It only works if it has mass. Mass is that you have to have mass or you're not going to interact with anything.
Forces. I made an entire video that goes into this, and again, the link is in the description.
Yeah, we have nice simulations of our fake fable story that you don't have much evidence to defend. It's just a story you've made up, a narrative. You know, it's like Hercules or Sinbad or some other fable you want to tell. This doesn't have anything to do with reality. I mean, it might not be as bad as Three Pigs, but it's close enough to just as bad.
If mass is just energy swirling in a single location.
Yeah, well, it really isn't. It's jiggling in a single location, so whatever.
With a swirling energy not moving, basically a stationary.
Yeah, it's basically stationary. That's right. It's moving here, then it's moving here, then it's moving here, moving here, moving here, moving here, moving here, moving here. And over time, it doesn't go very far from that single little location. And then you end up with the Heisenberg principle and all this other nonsense. Because yes, at any one moment, it isn't in this exact location because the next moment it's going to be in some other location. It's always on the move, but it's not going anywhere. It's undoing this with this, and then it undoes this with this, and this and this. It just keeps undoing everything it did yesterday. It undoes today.
Tornado. Then we're back.
So there are no tornadoes, no vortices, no swirlies, no any of that core shit. No, it's just not part of the real story.
To the definition of kinetic and potential energy.
So here he is again, talking kinetic and potential, and again, so the real definition is active and potential. Active energy, streams of energy that you can tap, and potential, which is trapped. and you have to untrap it before you can tap it. So the energy in a TNT is trapped energy. You can't tap it till you let the energy loose. Then you can tap the energy. You create kinetic energy that you can tap. That's potential.
That swirling thing isn't a perfect description, but it's a reasonable mental image.
It says you, okay? You define what's reasonable. I say it's unreasonable. That there's no evidence that you could guide any of these particles, or there'd be any structure for any of that, or any mechanism. It doesn't work. The energy economics, the thermodynamics don't make any sense, because you have to have very regular speeds to be in orbits and all of that kind of crap. This is about magnetic objects levitating, okay, in positions. It's not about things swirling like gravity.
Good enough to get a rough idea. And that's almost the entire story.
Okay, so again, he says so, right? But that's the story. That wasn't much of a story. He didn't say much, didn't describe much. He certainly didn't draw anything. He certainly didn't show me anything.
Energy is motion and forces, and it's unchanging.
So no, it's matter and forces, and the motion is the byproduct of the energy. So there's no motion and forces. There's forces first, then motion.
Sloshing into this form and that. It's somewhat analogous to how the atoms of the universe can change form.
So it would be easier just to say it's analogous to a vessel, okay, with little objects that had perpetual motion bouncing inside the vessel, and they have a constant speed, and they just keep bouncing inside the trapped vessel. And then you start injecting pieces of matter that reflect the little BBs. And you'll see then how the universe is functioning, essentially. It won't be complete, but it'll give you that vague idea of why things move around. They move around because there's a differential in pressure. That's it. You have to at some point be exposed to a differential in pressure to have motion.
How dirt becomes grass, becomes a cow, becomes a person, which becomes dust, and the cycle renews.
Yeah, well, you're supposed to get more elemental. You're not supposed to be analogizing to something more complicated. You're supposed to analogize to things simpler. That's how you teach something. You teach it by going simpler, not more complicated. You don't make comparisons to things that are harder to do. You make things that are comparisons to things that are easier to do.
There's one final twist to the whole thing. While energy is often said to be conserved because of Noether's insights.
Oh, I mean, it's just too silly. It's conserved, and they realized it 350 years ago. They didn't need Noether to discern it. It seemed a fact that you could sort of know it in your own experience. You could see the fire created heat, and the soot, and the this and the that. I mean, obviously, Galveston, whatever his name was, in France, the guy who got killed for, in the revolution, did all of those experiments where he reduced matter, and heated it and turned it into the energy and recycled it all and came up with the same thing at the end. Okay, I mean, it's all recycled, the energy. It's all a commodity that is completely undestructible.
About the symmetries of the laws of nature. Energy conservation isn't 100% true.
So it is 100% true, but yes, the only element that's a little dicey is the part where, a force hits matter. Matter moves slower than the force, therefore the force isn't moving the speed of light anymore, therefore the total energy of that bit of force in the universe is diminished because it didn't move the speed of light through the whole voyage, so it didn't travel as much distance, so therefore it didn't go at the same speed, and therefore its mass momentum was lower. But technically the matter's moving instead of the force, and the matter has just as much of an impact, so it's kind of replacing the force as an influence in the universe and as a source of energy, so in a sense it is conservative. But the fact is that whether matter absorbs any energy, real energy, from the universe, it doesn't matter, because the fact is the energy gives it back as soon as it stops moving. So as soon as a piece of matter stops moving, it gives back any energy it has absorbed.
The universe is expanding, and it's filled with a field.
So they say it. They just say it. It's expanding because we say so, because of one tiny little weird little fact that things redshift with distance, and we've decided that means there must be space creation. So even though we've never seen it, we can't test for it, it's kind of preposterous. We know it doesn't happen in our real world. We know things don't go further apart. We know that New York and California aren't getting further apart. We know none of this crap is actually happening. They're going to keep saying it as if they proved it. They never proved it. It's just a story, just a fable, just another story about what really happened that is just fake news. Fake science, fake news.
Field of constant energy density. Constant density.
Yes, there's a constant. There's only a certain amount of little bits in the universe moving the speed of light. And they all have a history. You could follow them through their whole history in the universe. They've always been somewhere doing something. Always, always, always. Always.
And expanding volume means that the energy of that form, which is called dark energy, by the way.
So, we call our magical, fabulistic, gremlin super grembloid. It's just
energy is increasing. And in an expanding universe, energy isn't conserved.
So again, it's just too silly. Obviously, yes, if the universe is expanding, the energy is diminishing in value because it's traveling more distance, and so it's got to be losing energy because it has to travel more distance, and it's still only going the speed of light, so it's doomed to failure. But that's not the reason why the universe is getting cold. The reason why the universe is getting cold is because all those little photons, all that little bit of energy, frankly, you have to have some explanation for how it gets back into the universe with the stuff that doesn't hit any matter. Where does it end up going?
Furthermore, when you talk about the fact that distant galaxies look redder than they should because of the expansion.
So furthermore, he says, no, that's the only more you have. It's the only reason why you believe in this expanding universe bullshit is because of redshift. There is no other reason. There is no other compelling cause for the effect. You created the effect of your silly expansion theory based on redshift, and there was no other reason you did it, and so this is the only reason.
Space, that has a consequence. You see, the amount of energy carried by light depends on the color of light, and the redder light has lower energy. Thus,
all right, so there's lots of other theories. Frankly, I spent 5 minutes one day saying, okay, how else could you explain redshift? Well, there's scatter. So if I hit a hydrogen atom, lots of hydrogen atoms in empty space, I hit a hydrogen atom and I'm a photon, I'm going to get scattered by the elements of the atom, the electron, the protons, and I'm going to end up, and when I scatter that light, that is when I deflected a tiny bit, bits of it, I lose a tiny percentage of my wavelength. So all I have to do is hit a few million hydrogen atoms on my billions of light years travel. So I'm traveling a huge amount of distance in space. It makes perfectly good sense that I'm going to hit some hydrogen atoms and I'm going to be scattered and I'm going to have my frequency lengthened, my wavelength. There. A mechanical, physical explanation for the phenomenon. No woo required, no space creation nonsense. No notion that the empty space between everything is somehow, there's more of it being created and it's pushing things away from each other. I mean, it's an extraordinary UFO-ish kind of claim, and they have no evidence for it. And they just pretend there's no possible other explanation. Well, yeah, there are. Tired light as an explanation works.
It appears that photons of light from distant galaxies have less energy than they did when it was emitted.
So again, it has nothing to do with how much energy the little bits that make up the photon have. The wavelength has a consequential effect that obviously the closer the little bits are to each other and the higher their concentration, the more effect they're going to have on something. But it has nothing to do with more energy per se. There's the same energy in the bits. It's just that the arrangement does make the bits capable of causing effects. So I could blow some wind. I could blow a lot of wind faster. I could do it faster and faster and quicker. And it's going to seem like more energy because there's going to be more pressure for an instant. But overall, it's the same amount of energy.
This implies that in cosmological situations with a changing shape of space-time, energy is also not conserved.
So again, more reason not to believe that. I mean, why would you break something fundamental like the law of conservation to support a theory that is based on no evidence?
And this is a universal truth.
So again, he just states it. What does that even mean? And this is a universal truth.
In general relativity, in which the size and geometry of space and time are unchanging, energy isn't necessarily conserved. You see,
again, it doesn't make any sense. You can't make energy, and there's no conceivable way to destroy the energy. So it's just such nonsense. There's no mechanical way to undo its existence.
Noether's insight relied on the mathematics of unchanging space and time.
So he said her name again, neuter. Aren't you getting the impression this is way overhyped because he didn't even explain what the magical statement was? No, it's just a piece of cruddy math. Okay, it doesn't have anything to do with reality.
Release that condition, and Emmy's mathematics no longer applies. The lack of conservation of energy.
So it doesn't apply, but it applies. I don't know.
In general relativity is a complicated one, probably worth a video or two of its own. However, that.
Yeah, just what's worth a video or two is why should I believe it? Where do you think you have any kind of compelling, either in specific power of a piece of evidence or a volume of evidence? You neither have a potent piece of evidence nor any volume of evidence for these fables. Nothing. You're just telling us a story that could be true if it was possible for us to draw this in some way. We could make it somehow work as long as we didn't care to figure out what's causing the vacuum cleaner inside of every electron. How is every electron sucking space? As long as you don't have to know how it does any of that stuff, your model can work. But it can only work if you have a bunch of effects for which you have no definition of cause.
That's not the topic of this video. I put a link to a website that talks about it if you're interested, but be warned, it can be quite technical. So, at the deepest known level of reality, what is energy?
So again, they always use this word, at the deepest level, the deepest known. We're deep. We're deep. We're so deep. Up your own butts.
Force fields and objects that interact with them. That's potential.
Force fields and objects that interact with him. La 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 la.
Energy. Kinetic energy is the motion of the fields. Remember that mass is.
Kinetic energy is the motion of the field. So you get it? How nonsensical it gets? That's supposed to be a bunch of massless particles that can't possibly have any momentum. But that's the kinetic energy. That's the stuff that has the kinetic energy. No, the matter has it. Too pitiful.
Mostly moving fields. That stationary tornado thing.
So again, this vortex thingy, blah blah blah. Imagine spinning tornadoes. Blah, 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 blah. Isn't it fun? That's all that's for. Somehow you're entertained by having your brain like you're a little kid with a little spinning thing, in your crib. And vortex. Woo! It's vortexing!
Kinetic and potential energy of all kinds slosh back and forth into one another in an endless dance, changing.
Yes, endless dance is a nice way to say it, I suppose. I mean, it's an endless chain of causes and effects, and all of them are physical. The energy is physical, and the matter is physical. It's all physical stuff, and there's rules governing the physical interactions. And the rules are really simple because it's really simple stuff. It's really physically simple as you go down. As you get deeper and deeper, the fact is it gets dumber and simpler.
Identity, but never changing the amount forced to be the same by the mathematical.
Okay, so he just says there's no conservation in his catches of relativity and expanding space, breaks conservation, and then he goes back to it's all conserved when their own theory says it's not.
Structure of the laws of motion. That is, unless you're talking about the universe as a whole, and there, energy conservation is a more complicated thing.
Right, so they have rules. Okay, yeah, there's no expanding space here on Earth. There's only expanding space in space. Catch 22. And Anyway, till later. Have to go, and yeah, we're almost done, but too bad. We'll have to wait for me to finish. You won't have to wait. I have to wait. Alright, should be finishing up here. So it does say there, energy is the interaction and motion of fields. Not really, it's the motion of matter. And what causes the matter to move is the field of real particles. How many crows fly into you. I mean, the fields are made out of real stuff that has real momentum.
Hearing that you revisit the meaning of the words energy and conserved.
Yeah, right. So, you didn't even give a good definition of the meaning of the word energy in this thing. So why would I revisit something you didn't even define? And conserved, you're just playing a game. Like, yeah, maybe it is, maybe it isn't.
From one point of view, energy is terribly complicated, while from another...
So, right. Except for the very obvious fact that it's really just momentum. So the little bits of a photon have momentum. They can impose it on something. Atoms can have momentum. Electrons can have momentum. It's just mass and velocity. That's what the universe is made out of. Mass and velocity. The force is always going to be invisible. And it doesn't do anything till it hits something that has mass. And it gives it velocity. The end of the substance of the story.
It's breathtakingly simple. It's a delightful and dizzying topic with
delightful and dizzying. I just hate this. Everything has to be, all the lilies have to be gilded. Everything has to be tarnished with this fake, faux importance.
Layers upon layers, and one that is always fascinating.
La 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 la. Just your storytelling. There's nothing fascinating about people just keep telling silly stories that they don't have any evidence to support. And that's very depressing, not fascinating.
Okay, so that was an incredible topic with many different levels of complexity.
I guess he says that to about every topic.
If you enjoyed the video, please like, subscribe, and share.
La 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 la. Why? Why should they do any of that stuff?
And keep on thinking about energy, which is one of the...
Oh, whatever. Just, promoting a video that's supposed to be basically, this is already paid for by the government. Okay, so, whatever.
The deepest and most fundamental topics of modern physics. And that's
the much pile of crap, convoluted, contrived mush. Elitist, special club with a little decoder ring crapola.
saying a lot because, well, as you know, physics is everything.
Whatever. Yes, physics is the only subject. Everything that happens is a physics experiment. My brain is in the process of doing physics experiments. The byproduct of them is me saying the byproduct of them. That's the byproduct of the physics experiments. Anyway, so enough of video. Well, let's just play the last little killer bits. Alright. So, written and presented by Don Lincoln. Dr. Don Lincoln. Anyway, okay, outro music. The pain. Anyway, so enough of a video. Nothing personal. It's just that, it's terrible that they pretend this science has any real investigative integrity. Like it's somehow made out of really arduous and intense scrutiny and testing. That they really tested all these ideas and really tested. They didn't do any of that. And it's very sad. And again, they just keep promoting it as if they just don't tell the truth about what actually is the ragged history of these ideas. These ideas aren't born immaculately. There's a lot of corruption. Anyway, till the next time. Enough. So this has been, draftphysics.com, debatephysics.com, but nobody's can do the debating thing, unfortunately. People with physics education and with points of view and opinions aren't capable of apparently expressing them in any kind of reasoned manner to make arguments. Even Don Lincoln, who has responded in a few comments, and all the comments have is mush in them. We're right, you're wrong. That's the extent of his capacity to argue any of the subjects. But anyway, till the next time and such, and so forth and whatnot.